Hi class, this is the 10th lesson for geometry, but today I want us to look at circle theorems. Basically, when we talk about theorem, it's like a rule we apply when solving a problem in geometry. Though we don't only have theorems in geometry, we have theorems in different cases of mathematics. Even in algebra, we have theorems. Yeah, in functions, advanced, and some basic mathematics, we have what we call theorems. Yeah, so they are similar to formulas. For example, if you say area of a triangle, you can say half multiplied by the base multiplied by the height. So as long as you have the base, you have the height, you can plug them in, then you'll be able to find the area. Unlike theorem, you don't find a particular parameter to put in, but it is like a rule, a statement that you need to follow. Yeah, a principle. Yes, you need to follow. But mostly in geometry, you should be able to visualize that theorem. Yeah, this is the theorem for a particular concept in circle geometry, and this is what it is trying to say. But you need to understand the part of a circle so that you'll be able to interpret that particular theorem. Now let's see what this theorem is all about. This theorem is saying this theorem is saying that the angle subtended at the center of a circle is twice the angle subtended at the circumference. You need to understand what is meant by subtended. Of course, I believe you know what an angle is. As long as you have come to this far, you should be able to understand what an angle is. But you need to understand the meaning of the word subtended. Then when we say center, of course you know center. I believe that you don't need to do mathematics to understand the meaning of the word center. Yes, but if at all you have to do mathematics, I believe you find it easy to know the meaning of the word center, the center of the circle. All right, of a circle is twice, two times, double. All right, twice the angle subtended at the circumference. You also need to understand what is meant by the word circumference. If you don't understand the theorem, um, for beginners, you need to memorize the theorem. Yes. But if you can only say this, you cannot visualize it, you cannot interpret it in diagrams, well, I don't believe you'll be able to solve the problem. Memorize this for beginners. Try to know what it is all about. Yes, in a circle. Be able to identify the part of the circle, especially those that are mentioned in the theorem. Then you can see this is a problem for us to solve. See? Now you can see the diagram, the two diagrams, they look alike. The only difference is we have a line here, which is what a chord. Here we do have a line here. Yes, but this one goes like this one goes like this, but that one doesn't matter. That's why we have what we call the theorem, the principle, yes, the pattern to follow. Yes, because we have different theorems. You should be able to remember them all. You should be able to remember all of them. Yeah, so that you'll be able to be comfortable in the exams. Now let's see. Let me try to interpret first what these words are all about. Now let's say here is a circle, yes, and this is the center. Now the angle subtended at the center of a circle, the angle that is subtended at the center of a circle. Now look at the center here. Let us say we have an angle. Now we have this one is a radius, this one is a radius. Yes. Now, but okay, let me don't say that. This one is a radius, this one is a radius. Now, we have an angle here. Yes. But this angle is formed by this radius and this radius. But the question here is where these radius are coming from the center. This radius, sorry, where these radius are coming from. These radius are coming from the circle. See, the angle subtended at the center of a circle. We are discussing a circle here. Now, this radius and this radius, they are coming from the circumference. They are coming from the circle, circumference. Is that understood? But one thing I want to also let you know is that if you starts from this point and it gets to this without completing the circle, we call this one an arc. So some textbooks, some authors, some teachers, they say the angle subtended at the center of a circle or the angle subtended by an arc. Yeah, the angle subtended by an arc at the center. I hope you get it right. The angle subtended, yes, the angle subtended by an arc. You see, now we have this arc. This arc produces what? Two radius. They meet here to form this angle. So that is one. And let's see again. The same arc that forms the angle at the center is the same arc that also forms an angle here. Do you see that? This arc forms an angle here. The formation of an angle by a line, the formation of an angle by a curve, by a straight line is what we mean by the word subtend. Subtend as the base word, subtend. So this angle here, yes, it is subtended. Now, why the word subtended here? Subtended or subtends or subtend. Now, this angle is basically formed by two radii. We have this radius, we have this radius. The radius, the two radii form the angle. So you see the word I use form. The two radii form the angle. But these two radii, they are coming from the arc. The reason we have the word subtended. So this angle is subtended by this arc to form this angle. The same arc, yes, that subtends this angle is the same arc that also produces this angle. So this is what this theorem is all about. So just try to memorize, just try to understand this pattern here. When an angle is subtended by an arc at the center, the same arc also subtends with another angle, but at the circumference. These two angles are what this theorem is all about. So what the theorem is saying now is that this angle here, when you multiply it by 2, it gives you this. So basically, this angle is bigger than this one. This angle is larger than this one. This one doubles this one. So if here is 40, this one is bigger. So this is supposed to be 20. If this angle is 60, this one's supposed to be 120. So now you can see what it is saying. The angle subtended by an arc at the center, this arc subtends this angle at the center, at the center, is twice, meaning it is 2 times the angle subtended at the circumference. Remember, this one is a circumference. I hope this one is clear. Okay, now the image is a circle. Yeah, the diagram, the picture, the figure is a circle. But when it traces through, this one is the circumference. It goes around the circumference. If you start here, you come to this without completing, it is an arc. We have a center here. This arc subtends an angle at the center. The same arc subtends another angle, but this time at the circumference. So this angle and this angle are related. How are they related? This one is 2 times this one. What if this one is 50? What should be here? This should be 100. This is what this theorem is all about. You know this theorem, you memorize this, try to figure it out, try to visualize it. Then when you have a problem to solve, you'll be able to do it. Now you can see if this is 50 times 2, 100. If this is 20 times 2, 40. If this is 60 times 2, 120. If this is x times 2, 2x. All right, now let's see, we have a problem here now. Yeah. Now, don't be confused because of this line. We have 50 here. Now, when you take a look at this problem, You already know that here is a center and it is identified as what? O. Okay. Now we have AB. We have from this point to this point. So from A to B, this is an arc. This arc subtends an angle here. Do you see that? An angle here. The same arc subtends an angle where at the circumference here. So once you see the picture, what should come to mind? Say, oh, this is what I learned from my teacher, that this angle and this angle, they are related. There is a relationship between them. So once you see this, you say, oh, is it not what the teacher was saying in class, that the angle subtended by a particular arc at the center is twice the angle, the same arc, not just arc, but the same arc subtends at the circumference. So this one is twice this one. But the thing here is we have to find angle BCA. Yes, angle BCA. We want to find this angle. You learned from your teacher that this angle is twice this. Then here today in the exams, you want to find this angle. But the thing is, what your teacher told you is that this angle is twice this. But how can you find this angle without knowing this one? It's not possible. That is the reason the examiner decides to give you 50 here. With this 50, of course, you are given a line here. This one is a chord. Some authors, some textbooks, they will say the angle subtended. Instead of saying an arc, they will say the angle subtended by a chord. You see, this is a chord, the ends of the chord. So it could be an arc, it could be a chord. Please, let's understand this. All right. Now, we have 50 here. This is what we learned from our teacher. This is what we see today. We get confused. If we know this, we can find what the question requires to find. But the thing is, we don't have this one. But the only thing the exam does for us, the examiner, we are provided with this angle. But note that here is a center. From this point to this point is a radius. From this point to this point is a radius. In one circle, no matter the number of radii you have, all of them are equal in length. So it tells you that this line and this line, they are equal. This and this, they are equal. So if this line and this line, they are equal, let's extract this out and see something. Yes, we have this, we have this. Here is 50. This and this are equal. What figure is this? This one is a triangle. A triangle where two sides are equal is called isosceles triangle. Isosceles triangle. All right. So what is said about isosceles triangle? For isosceles triangle, the base angles are equal. But how do we identify the base angles? This length side and this side are equal. These two sides meet here to form this angle. So the remaining two angles are what we call base angles. And these base angles are always equal for isosceles triangle. So if this is 50, here should be what? 50. I hope this one is clear. So in that case, we can say that this angle here, how do we call this angle? Angle OAB. So we say angle OAB is equal to 50 degrees. Yes, if this is 50, this is 50. I hope this one is clear. All right, so that means this angle here is 50. You need to understand what we are trying to campaign here. From what we learned in class, from the theorem, this angle is twice this. This angle is twice this. We want to find BCA, this angle, this one here. Well, how can we find this without knowing this? With the help of this one given to us by the question, now we are able to get this. Now that we know this one, we should be able to find this one, because for any triangle, not a specific triangle, for any triangle, the sum of the interior angles is 180 degrees. So if this is 50, this is 50, it remains this. So if this is 50, 50, we have 100. Yes, from the 180 degrees, it means this one is 80 degrees. So now what do? We say this angle AOB, we say angle AOB is equal to 180 minus 50 minus 50 minus 50. So angle AOB. So 180 minus 100 is 80 degrees. Yes. So now this one is 80. Is this what we are finding? No, this is what we are finding. Now that we know here is 80 degrees, it is now easy to apply what you learned from your teacher using this theorem, that whatsoever angle that is here is twice the one that is here. So now we can say our required angle BCA, we say angle BCA is equal to 2 times, oh, sorry. According to the theorem, the one at the center is twice the one at the circumference. So the one at the center is this one, angle AOB. So we say angle AOB is 2 times the one at the circumference, which is what? BCA, which is angle BCA. Yeah. But what is angle AOB? Yeah, AOB, this one is what? Is 80, this. So this is 80 degrees. This is 2 times angle BCA. So we divide by 2, divide by 2. Yeah. So what do we have now? Angle BCA is what? Is 40 degrees. So I hope this one is clear. Yeah, it appears to be so difficult, so tricky. But once you are able to remember what the theorem says, for beginners, you memorize. But if you think you can understand it faster, that one is a very good advantage for you. So thanks for watching. Don't forget to follow, like, share, and comment. See you in my next video.